Well, g'day, Max here again. Welcome back to the shop. Well, we're just going to take a break in our arbors, although I will say I did complete the heat treating on them. So the other three are ready for grinding. We're going to take a break. We're just going to slip in this other job first. So I guess a lot of you would have seen these drawings. There's a few of the copies starting to float around now. So Stephen Goss Winter's indicator, quill mounted indicator holder. Actually, I've been needing one of these for a long time. I've just been getting away with my last word, Starrett, and I do have the DTI that will fit this. I never use it because it's a pain in the ass to use. It's a brown and sharp one, but it'll fit nicely into this. So, looking at these drawings, it looks, at first glance, it looks like it's all pretty basic, but there's a couple of challenging aspects in this drawing. Mainly work holding is I think people are going to find the biggest challenge, I would expect, but we're going to do this in such a way that work holding will not be a challenge. So let's go through these drawings and see what we got. Okay, here's the first item. I'm just going handheld here. Just a bit of 6mm material. It says mild steel. You've got a couple of radiuses here. That's all pretty straightforward stuff. Just got to be careful here. These holes are on the other side of centre. So what I've done here is just worked out the triangle. We're 7.68mm from our centre point to reference these points here. So this is a good rotary table job. Actually, what I'd probably do is machine this out of solid bar stock in the lathe, and then we'll put it in the rotary table. We'll do these end radiuses and we'll do the holes. So as it's first drawing on the list, I would normally make this part first, but I don't have a 5mm reamer. There's a diameter 5 H7 tolerance hole there, so I've got a reamer on order. So H7's minus nothing plus 0.012. So we'll tackle that. We might rough it out anyway today. We've got a couple of pins to make. It's all pretty straightforward stuff, nothing technical there. You've got a bit of a tolerance here, and that's for plus nothing, minus 0.02. So that'll either, that tolerance combined with this H7 tolerance on this part. So that will be anywhere from a press fit, size for size, to just push it in with your finger, and I think they Loctite them in. Yeah. So yeah, these parts here, what I'm going to do, I'll just do a little sketch down here. I'm just going to do them back to back on one piece of material, and then when everything's finished I'll just part them off. Boom, done. There's no secondary turning the parts around and trying to hold them. So yeah, that's pretty straightforward. It's just an assembly drawing. The only tricky part on here really, you've got a fine metric thread, M10 by 1mm pitch to cut there. Not a big drama. These dovetails. Okay. Now, because they're only 5mm at the narrow point, you won't get a, well, I haven't got a dovetail cutter that small. So there's a couple of ways around that. You can slot that with your quill with a 60-degree tool, or you can just grind up a tool. Probably the best option would be to use an old Woodruff key cutter and grind all the teeth off and just leave one tooth remaining and grind the form on that to 60 degrees. So that's also doable. So I don't know which way. I'll make my mind up when we get to this part which way, how we're going to tackle that. But as with the previous ones, they'll be machined off one stock bar either end, and we'll complete the process and then chop them off as finished pieces, and then they'll have to go back into the mill for the radius feature. Now these ones here, same thing, they'll just get out of one piece of bar back to back, and we'll chop them off when we're finished. So we've got some nuts to make. So I think we'll do the nuts first. We can do that. I'll have to see if I've got any material for the washers. So our nuts, free cutting mild steel. I'm going to make them out of stainless, and yeah, we'll just machine them off out of a piece of bar and then part them off as finished units so we don't have to rechuck them. So over to the lathe and let's get cracking. Okay, I'll just pop back to this one for a sec. There's something funky going on with this drawing here. It's showing two different types of dovetails, an external and an internal dovetail on the same part. So side elevation and plan view, or either or, yeah. So this one here should have been drawn like that. So the dotted line there represents this area here. So for some reasons unknown to me, I don't know why it was drawn that way. I'm sure he's got some particular reason. Maybe there's some indicators around that suit that style of dovetail, but who knows. Okay, we'll have a bit of 30mm 316 stainless chucked up, so we'll get our pair of nuts out of this, and should be good. Okay, so the nut OD is 20mm. And we are 20.52. So we've got 0.52 to come off. The OD is actually a finished 20mm after knurling. So we'll take this to 19.7. And we're there. Okay, let's clean up the end of it. So we've got a M5 by 0.8 thread to put in through the nut. Okay, now our tap. What have we done with that? Here we are. Now we'll just start this in the lathe and then we'll finish it with a tap wrench. With the lathe slow speed. It's such a small thread, I'm afraid of it bottoming out or breaking the tap. This is one of these taps, it's only got a very narrow neck on the top of it there, so no doubt should break quite easily. Okay. So the next operation, we've got our knurl to put on. Now let's get set up for that. Okay, we have our straight knurling tool set up. According to the drawing, it's a RAA knurl, which is RAA is a classification for a straight knurl. Now it says RAA 0.5. Well, that's the 0.5 is the pitch of the knurling tool. Ours is 1mm pitch, so it's a bit coarser, but that'll be alright. Because it is stainless steel, yeah, it's pretty tough stuff to knurl this. So. Bit of oil. Okay, well that looks quite acceptable. Okay, so what we have left now, we have to reduce this diameter at the rear down to 10mm, and we're not going to leave the front plain. We're going to scallop it out a bit. So we'll just check the OD of our knurl, because it's supposed to be 20mm according to the drawing. and we're, what are we, 0.01 under. So I think we can live with that. It's only a knob. So that's the reason why, yeah, we turned these to 19.7 instead of 20 millimeters. So our finished knurl comes up as per the drawing. Okay, we've got a form tool in here, so we're just going to stray from the drawing for a moment, and we're just going to turn a radius feature on the end of the nut. So we'll bring it, I'm not big on plain nuts. This scribing block here is my great grandfather's, and he's turned a radius feature on the end there, so we'll do the same. So if I left it plain, I'm sure he'd roll over in his grave and go, "You're slack bugger, turn the radius." So here we go. Okay, I might just slow that lathe down a little bit. Okay. Now I'm just measuring the depth that we went in, as I zeroed the dial before we started, so when we do the other one it will be the same. So we've gone in 0.75 millimeters. So I'll just write that down, 0.75. Okay, that looks good, so we'll flip her over and do the other end. Okay, before we flip it over, what we do here is we don't touch our cross slide dial because our tool is already centered on our radius. So we just wind the carriage back well out of the way. And we can flip over. And do the other end. Okay, so if we're looking at the drawing, the next part we're doing is this diameter here. So we'll, I'm going to put a radius in here, I think, rather than just finish it with a square corner. Just make it look a bit better. So we'll use the parting tool, we'll plunge in and take most of this out with the parting tool. So we'll just set the depth of our parting tool because the nut is 4 millimeters wide. So I'll set the tool 4.5 millimeters away from the face. check on our width. So we've got 0.37 to come off our width. We'll go 1, 2, 3. Okay, I think that's close enough for a knob. I think that's 10.03 is close enough for me. So what we'll do now, before we flip it and do the same thing to the other end, there's a chamfer to go on here, and then we can part them off. So we'll just do that. It's only a small chamfer, so we'll just do it with a file, I think. So the added benefit of doing the job this way on each end of the bar is we've got something to hang on to for our very last operation, which will just to polish them up. Okay, we're ready to part it off, so a bit of WD on it. And there is a small chamfer on the end of it, so we'll just pop that in with a file. What we'll do so we don't lose it, we'll just start the tap, we'll put the tap in, and then I can catch it. Okay. I'll just get a pair of pliers and nip the fuzz off the end of it. Okay, we just have to take the burr off the 5mm hole at the back up there. So I've just got a tap in the lathe chuck, just grip very lightly. Screw the part on. Of course, if you've got a bolt, use a bolt, but I never work with 5mm threads, very rarely, go that small, so. try a little countersink that works. Obviously not that one. We'll try this one. Okay, that's all it needs. Okay, here's our completed knobs, 2 off. So we'll wrap this one up, and the next video we'll do probably the parts that they screw onto. So, anyway, thanks for watching. Have a good one.